Hi, I'm Thibana Govindaraja, undergraduate at University of Malta. Today, we are going to see about how to interface 4x4 Matrix Keypad with atmega 32. First of all, do you know why we need keypad in our projects? We need for the security applications, such as entering the password. Second one, for the main selection, such as we need to select the item 1, 2, 3, or like that. And for the data entry, for the embedded system. For example, entering the temperature, like that. There are numerous types of keypads. For example, keypad with 8 keys, 12 keys, 16 keys, and so on. We can choose the keypad according to our purpose. For example, let me take, we are choosing a keypad with 16 keys. If we connect that keypad with the atmega 32 directly, then what will happen? We need 16 GPIO, that means general purpose input-output pins, to directly connect with atmega 32, which is the half of the pins of atmega 32. So, as the result, the remaining pins are not sufficient to connect other modules. So we have to find some alternative ways to reduce the number of pins needed to connect. That's what we are going with the concept of 4x4 matrix keypad. In this concept, we only require 8 GPIO pins. By the way, this is totally my side tips book. This article was written by me. That's why I am explaining to you by using my own article. Here, this is the setup of 4x4 matrix keypad. Here, 8 wires are coming out, and you have to embed it with the atmega 32. This is the internal setup. 4 wires are coming from rows, and 4 wires are coming from the columns. In the normal state, that means when no keys are pressed, there is no connection between the column and the row. But when the key is pressed, row and column make a contact. First of all, we just look how we are going to interface the keypad with the atmega 32. In this example, I connect it in this way. I embed it with the port B. For some modules, there are specific pins. For example, for the fingerprint sensor GSM module, there are certain type of pins. You have to connect it with them. But here there is no restrictions to you. You can connect with any pins you want. For example, if you are taking a keypad with 12 keys, you go on with the setup of 4x3 matrix keypad. Then you need 7 GPIO pins, and you can embed 7 GPIO pins with any of the port and any of the pins. Like that, here also you can connect with any of the 8 GPIO pins, and here I'm going with the port B. And to display to you the key I have pressed, here I have connected 16 into 2 LCD display. What is mean by 16 into 2? In one line, you can enter 16 characters and you can enter up to 2 lines. That's what you are showing as the 16 into 2. Here I have connect LCD display in 4-bit mode. You can connect LCD display in different modes. For example, you can connect it with 8-bit mode, 4-bit mode, or I2C mode. I2C mode means you are connecting only 2 wires with the keypad, with the atmega 32. 4-bit mode means you are connecting 4 wires. 8-bit mode means you are connecting 8 wires. But sometimes you may confused that I have shown 6 wires. Then why I am telling that I have connected in a 4-bit mode, and for the 4-bit mode we are only using 4 wires? Because we are talking with the number of wires of data pins. That means from D0 to D7. Here we have only connected D5, D6, D4, D5, D6, D7. Here what's happening is the data is divided into 2 parts, and the 2 commands will be sent sequentially through the 4 data lines. This 4-bit mode is introduced to serve pins of microcontroller rather than 8-bit mode. But the disadvantage is it's little bit slow compared to the 8-bit mode. Okay, now let's come to our topic. How Keypad is working. As the first step, what we are going to do is, we are providing the logic 0. That means we are grounding the raw wires. And we are providing logic 1 to the columns. And when the key is not pressed, there is no connection between the rows and columns. So, if you are measuring the values, all the rows will be zeros and all the columns will be ones. So, if the data read from the column is 1, 1, 1, 1, that means all ones, then it clearly shows no key has been pressed. And if any of the column changes to 0, then we can detect one of the key has been pressed. Because whenever we press the button, rows and columns make a contact, get short, so that column also change to 0 as the result. So from that means which column has changed to 0. From that data, we can find out the column number. If one of the column bit has 0, then we can clearly see the key has been pressed. For example, let me take, we are getting the data as 1011. Then it shows C to have been pressed. If 1101, then we can say C3 has been pressed. So from that, we have found the key is in which column. Then we need to find it's in which row. Then only we can able to find which key has been pressed. So let's see how to find the row number. row number, what we are going to do is, after finding out the column number, we are going to make all the goes to the logic 1. Then we are going to grab rows one by one at a time. For example, at the first step, we are grounding R1, then R2, thereafter R3, thereafter R4. So let's take that in that order. We are grounding R1. At the time, remaining 3 pins, R2, R3, R4, are in logic 1. R1 is only in the ground state. Then we are going to read the columns. So only if the here in the R1, one of the column value will change to 0. If the key is not in R1, then there will not be any change in the value of the column. So from that, we can deduct the first key is in R1 or not. If it's not in R1, then we have to ground R2. And we have to check any of the column will change to 0. If so, we can find out the key is in R2 row. If not, we are going to ground R3 and check the column again. If doing the process for all 4 rows, we can find out it's on which row. In this example, when we are grounding R2 only, one of the column value will change. So let's see the how. Here what we are going to do is, initially we are defining the frequency of the CPU. Thereafter, we are including some of the files. First step, I have included the library for the LCD display. And this is for the atmega input-output pins. In this file only, the ports are defined, and this is for the delay. And here, what I have done is, I have defined some terms using macros function, because then only there are no naming problems. That means when you are doing a large code for the project, there are a lot of modules in it. Then you are not remembering, I have connected the keypad with which port. You may confused. I have connected it with port B or port C or port D. So for every time I have to scroll up and check whether, oh, I have connected with port B. Then I have needed to write the code. So the easiest way is, we can define the particular term with the name which we can remember. So I have defined port B as key PRT and as the data direction register as the key DDR and as the pin B as the key pin. And thereafter, I have assigned the array. Here I have assigned the array for the normal keypad, not for the port one. That means I have assigned the values like this keypad. 1, 2, 3, A, 4, 5, 6, B, 789C asterisk 0 hash D. This is what I have assigned, and you can give any value according to the keypad you are using. If you are using keypad with 12 keys, then you are using the 4×3 matrix. Then you have to assign the array into 4×3, and you don't need to give these values if you are using the 4×3 matrix array. And according to the keypad you are using, you can assign the value as you wish, according to your need. Okay, then let's see. What's the function char key find did? Here, what we are going to do is, we are defining the data direction register, DDRB, as 0x. This means X. This shows it's on hexadecimal. If it's on binary, we will use 0B. Since in hexadecimal, we are using 0x. And F naught means it shows in output and input. And we are giving key PRT as 0xFF. Here for each and every line, I have explained to you why I have used these codes as like that. If you have read that, you can clearly understand why I have used all the things. Here, all rows are output and all columns are input. If you have seen the picture, I have connected the rows with PB5, PB6, PB7, PB8, and I have connected the columns with PB0, 1, 2, 3. So here F refers to the output. That means we have given all ones for the columns, for the rows. So rows refer to outputs and column refers to input. And key PRT we are given as 0xFF. And thereafter what we have done. Here we are using the do while statement. The difference between do while statement and while statement is, you might know, for the do while statement, it will surely execute at least for once if the condition condition false also. So it will surely enter to this do loop and make key PRT. That means port B defines as the 0 into 0, 0x into 0x. That means what we are defining is we make column read only. That means we can read the values from column only. That's what we are doing in this statement. And this means we are giving the delay. Instead of this, we can even use MS delay function also. That's not a big deal. And here what we are using is, this key pin refers to the value of the pin B. So it will read the value of the pin B and it will mix the value with the 0x into 0f. So that since we are using the AND, first row will be surely zeros and last row will remain according to the value of keeping. So here what we are doing is we are checking whether halak is not equal to 0x in 0x 0f. That means if the statement becomes false, it will go out from this loop. When it becomes false, if halak equal to 0x 0f, then this statement becomes false. So when it becomes equal, if no key is pressed only, it becomes equal. So from that, we can understand what's happening here. It's wait until it returns to the normal state. Because if we pressed earlier, it will take some time to come back for the rest position. That's why we are waiting here, whether it returns back or not. If you didn't put this statement, if you press the key for one time, then many values will be printed for the single press. Because you didn't give any delay for the time for returning back. That's why we are doing here. We are waiting until it returns back for the rest position. Okay, then we know if it's go out from here, it becomes to the rest position. Then what we have to do? We have to check whether any keys are pressed again. So here the condition is opposite for that. You have clearly seen halak is equal to 0 into 0f means it's on rest state. So it will remain in this while loop until it has been in rest. If the key is pressed, that means if it's not equal, if the key is pressed, we all know that one of the halak value will change. So halak will not be equal to all fours. So one of the value will be changed. So it will go away from this loop. And to ensure whether the key has pressed or not, we are again checking. That's why we are using two do-while loops. Here we are ensuring again. That's what only we are doing. Here there is some debouncing delay. That's why we are giving delay. Don't forget about that. And if you didn't give any delay, there might be some awkward functions. Okay, from this ensuring, we might know that one of the key has been pressed. So we have to check which key has been pressed. So as we have already told, what we have to do is we have to ground one of the row at a time only and find out that row or not. So here we are giving port B as 0xEF. That means we are giving 1, 1, 1, 0, 1, 1, 1, 1. Check for first key in first row. If it's in first row, then one of the column value will be changed. So this will not equal to 0 into 0f. So it will enter into the if row, and we know that that value is in a 0th column, and it will break from this loop and go away. It will not go for the next statement. If the if statement is not correct, it will directly come here for the next part. In the next part, we are checking for the second row. That's why we are giving DF. 1, 1, 0, 1, 1, 1, 1, 1. And if it's in the second row, here hollow value will not be equal. If not, it will go for the third row, and finally it will check fourth row. And from that we can find it's on which row. Then we are checking again if it's in the first column or second column or third column or fourth column. And we are printing the array value. That means we have already assigned the array here. So if it's on 0, 0, it will here, or if it's on 3, 3 over here. So from that we can find out the array value because we have already defined it. And here what we have to do is we have set up the LCD. Here in the LCD.h library, which we have already included, have all sets of functions. Here we have just initializing it, and also we have calling the key find function, which we have already written about. Here I have explained it one by one. I hope you have enjoyed this article. By the way, if you have any doubts, don't hesitate to contact me over the LinkedIn, and my LinkedIn address is also Tibana Govindaraja. This is my LinkedIn address, Tibana Govindaraja. This is my LinkedIn address. I hope you enjoyed that. Thank you. We might meet in the next article. Bye.